In this quick video, you're going to see some more details about how to manipulate the mesh. I'm going to start off with showing you some tools and issues with using some mesh editing in SolidWorks. And then I'm going to jump to doing some mesh editing of the same part in ANSYS and ultimately show you that one of the key differences between the two packages for doing FEA is that you've got some easy to implement stuff in SolidWorks. However, you're limited in how much editing you can do to really tweak the mesh. Whereas in ANSYS, it's a lot more challenging to become comfortable with the tool. However, you have so much more power in actually tweaking the mesh to get the best result. So let's get started. So here's my SolidWorks model. I've already built up a new model for this example. Started off with just a sketch that was protruded into the Z direction with this weird bracket sort of shape. And then I did a second cut of that, cutting it through here. So you can see that I've not done a whole lot of effort to do things like radius and corners. I've left everything sharp, and it's a pretty basic model. So don't take this as an example of a really good realistic bracket. It's not. So with this, I will save it, and I can go to SolidWorks add-ins and I can turn on the simulation add-in. I'm going to use the static simulation again. And so now I've got the body selected. I'm going to right click and apply a material to it. And I think that I'm going to use I think I have some aluminum here. Not in the steel. I've got aluminum here in this category. And I'm going to use 6061 T6 aluminum. So that's a standard aluminum alloy that we encounter here in Canada. And I'm applied that to my bracket. Now for my fixtures, I am going to make a couple of key fixtures. I'm going to select, first of all, a point, and I'll fix that. And I'm going to select another point for a fixture. I'll just pick that one. Oops. I guess I want to pick that one. So I've fixed those 2 points. Now I might have a problem with the 2 points requiring that line be a fixed dimension, but I'll not worry about that for the moment. Now, if this is a bracket mounted to the wall, I've got one more fixture I need, which is I'm going to put a roller slider on that face. And so that should make this a bracket that's essentially mounted to the wall with the reaction forces appropriately to keep it in place. For a load, I'm going to apply a force, and my force will be not normal to the face I'm going to select. It's going to be oriented downward in that direction. And the face that I want to apply it to is that one. And I'm going to make this, 1,000 newtons. Now, if I was doing this for real, I would have a better idea of what that force was. But right now, it's an example. And so there we have our conditions. Now, the next thing I need to do is create a mesh. And if I choose the The mesh, I could pick coarse or fine. I'm just going to leave it as is. I'm going to look at the mesh parameters. I'm going to use a standard mesh. 2.4 millimeters. Nah, I want to make that a little bigger. Maybe 3 millimeters, 3.5. I can just type that number in, 3 millimeters. And here's the mesh that I create. Now, the mesh has some interesting features about it. It's obviously set itself up so that there's two elements here, and it's flowing normal to some of these curves here. I wonder what it's doing in the corners there. Well, it's a separate entity. So now that we have this this mesh, perhaps we can look at investigating the quality of the mesh. Whoops. And we can look at creating a mesh quality plot. We can look at the aspect ratio of the mesh. So what that means is how sharp and pointy the mesh elements are. We'd like to have mesh elements that are relatively similar in length and width and thickness. So sort of cubic mesh pieces, although tetrahedrons in the way that this model went. And this will show us the mesh elements that are not exactly close to being that. Now, we don't know why, and we can't easily see what that is because none of the display options let us actually see inside the model. We can go back to the mesh quality plot and look at some of the settings. We can look at something called the Jacobian, which is a matrix parameter indicating how easily these elements are to be solved. And this doesn't really tell us very much. I guess it would if we knew more about the details of the matrix, and we'll talk about that in another video. But for now, we can just make this kind of nonsensical colored plot. So we can go back to the mesh itself. We've created the mesh quality plot. We could make some mesh controls, and we can do some various things like we can select some different parts of this, such as these faces. And around those faces, we could make a finer mesh. So after making those changes, now you can see that we've told it that we wanted to have very fine mesh elements around this triangular region, and mostly because these little features in the corners might be problematic for us. And so with a finer mesh, maybe we can simulate those corners better. We probably should do the same thing for the other edge as well. Let's give that a try. And so there you see we've gotten finer mesh elements around both of those cutaway features. Now the other place that I'm a bit concerned is in the sharp corners. So I wonder if we can do something to improve the quality of the mesh there. So there we've got some improved fine meshing at those places where it obviously needed some more detail. Now we don't want to do it everywhere because trying to mesh everything with the fine size will just make a really large and unwieldy model to solve. So we now have an aluminum bracket where we've got some sharp corners, inside corners, which are going to be problems. We've got some sharp inside corners here, which are going to be problems. And we could do the same at the external corners, but in general kind of common sense approach, they might be maybe not as critical. But we can find that out with investigating different mesh options. So based on that, we can now run this study. And you can see we've got a deflected shape in the study that looks pretty wonky. Now, before we could have any faith in this model being correct, we'll need to do some hand calculations on this just to see if it does make sense. Let's see what the stresses look like. So our plot of stress colors is from blue to red, and that's entirely based upon what's in the model. So these numbers only have significance in the sense of what we ultimately solve for stresses. We don't have anything in there to show us really what's important. Now, interestingly, this plot shows us the yield strength with the red arrow here. So we've got anywhere where it's green, yellow, or red in this, we've actually yielded the aluminum, so we've permanently distorted the aluminum. And according to this, we've distorted the aluminum here. We certainly have in this sharp corner, and if you look into the sharp corner, you can see that because that corner is so sharp, we've got a stress concentration and a very high stress at this point. Now, how high is it really depends upon how carefully that we did the mesh. So we could go to a finer and finer and finer mesh in this region, and we would still find that it's still not fine enough. So if I go to this and show the mesh, whoops, you can see that the corner, even though I had stresses that were very much smaller than here, I'm really basing that on elements that are much too big to really resolve that stress. So we know that there's going to be high stress there, and that might be a feature in our design that could stand to be edited, but we really can't trust the numerical result of how high that stress is. Now, in contrast, what if we look at the corner over here, where you can see the scale of those elements, and if we look at the stress in there, there's not that much going on, as opposed to in this point where, again, the elements are much larger than the stress concentrations. But we know that there is stress concentrations there. So all I've done here is I've reset the color coding so that I'm only looking at the at what's smaller than the yield stress. So you can see that everything that's now red is an area that will be permanently deformed or yield. Everything that's anything that's yellow, green, or blue, even though it's highly stressed, is not going to yield, and when we release the load, those elements will go back to where they started, but the red won't. Now it's interesting, why do we have this here? And what's causing that? If we look in this region, the mesh size is relatively small. It's smaller than the features that were being reproduced, and there's good mesh resolution here. Now, we really don't know what's good and what's not good because we haven't done a comparative analysis, but we could now go and redo the analysis with a different mesh size and see if those features were still reproduced. And if they are, then we can start to have some confidence that we're yielding here as a result of the design of the overall structure in this zone. And we can think about what ways could we do to modify this shape to maybe make that a better result. In the case of over here, just like in the original bar example that I showed, these highly stressed areas are probably artifacts of my decision to have a fixed point at this end and a fixed point at this end. So they're not really mesh related, they're my fixture relations. Now I said that this video is going to be more about meshes and about editing meshes. And in terms of SolidWorks, we can change some of the settings. We can change some of the mesh edits, as I've shown with these mesh control tools. But as far as directly editing the mesh points, we're a little limited with that. Let's just recap. So right now I've shown you in SolidWorks a couple of ways to customize the mesh that you want to use. I've shown you a couple of features that you can look for in your own models that indicate a good mesh quality, a good mesh result, and some that indicate maybe artifacts either because of your meshing or because of your boundary conditions. So moving forward, we can't do much in the way of direct editing of the mesh in SolidWorks, but you'll see in ANSYS, yes, we can.